Again, welcome to Java programming language. And this will be part 2 of the elementary programming, which is basic Java syntax. So in these lectures, we're going to learn about Java arithmetic operations and also Java data types, and also how to write Java arithmetic expressions or numeric expressions. So first we start with arithmetic expressions. So for example, here we have 3 plus 4x divided by 5 minus 10, parenthesis y minus 5, a plus b plus c over x plus 9, 4 over x plus 9 plus x over y, parenthesis. So what we're trying to say is that here we have, again, the standard expression in college algebra, or I would say algebraic expressions. In mathematics, this is how expression will look. But again, in Java, we need to translate it in this form. In Java, plus is the same as plus, minus, division, they are the same, but multiplication is asterisk. So for example, in Java, we may say 4 times x, which is 4 asterisk and x. But we know in arithmetic college algebra class, 4 times x, we can just write 4x. Or 10 times y minus 5, we write 10 parenthesis y minus 5. In college algebra, parenthesis means multiplication. But in Java, we always have to specify the arithmetic operation. If it's addition, we have to write it. If it's multiplication, we still need to write it. So when we look at the 10 times y minus 5, in Java, we have 10 times, which is the asterisk again, y minus 5. Then times a plus 5 plus c. A plus b plus c. Then all divided by x. Since they are all multiplication, we don't need to put a parenthesis. So we divide all by x. So for example, here we have a plus. So 4 divided by x will be in a parenthesis. So we have 4 divided by x, the parenthesis, plus we want to have the combination of 9 plus x, then we divide by y. So we put 9 plus x in a parenthesis, then we divide by, again, y. Then everything is multiplied by 9, so 9 is outside. So here, this y is only dividing 9 plus x, and x is dividing 4. So we have 2 divisions. So again, we'll go through the arithmetic operations individually, but here, just to give an example, how Java arithmetic expressions look like. So we still have the plus. Again, multiplication is asterisk. We still have division and minus. Also, we are missing one operator here, which we call the modulus operator. In college algebra, we don't use modulus operator. Modulus operator is like a remainder. So if I said, for example, 5 modulus 2, the answer will be 1. Because 5 divided by 2, the remainder is 1. So the modulus operator, again, is a percent operator. We will see it soon. So this is how we evaluate expression in Java. The evaluation of the expression is almost the same as college algebra or arithmetic. We know the order of operations. Always in arithmetic or college algebra, we say always parenthesis is first, then exponents are second, then multiplication, division, then the last will be addition, subtraction. The same rule we apply in Java programming language, which make, again, logically correct, because if I write a program to find the answer for this expression, we want to get the same answer if we are finding the same expression in college algebra or in arithmetic. So again, the order of operations is the same as college algebra or arithmetic. So for example, here we have 3 plus 4 times, again, asterisk means times 4 plus 5 times 4 plus 3 minus 1. So parenthesis is first. So we are going to do addition first. And 4 plus 3 gives us 7. So we have 7 here. Now, next, we start with the multiplication or division. Here we have multiplication. So we're going to do multiplication first from left. So we get 4 times 4, which gives us 16. We have another multiplication, so that will be the third operation, 5 times 7, which is 35. Now we have only addition and subtraction, so we can start from left also. So we did addition first. 3 plus 16 is 9. Then next addition, 19 plus 35, which will give us 54. Then the last will be subtraction minus 1, and that gives us 53. So the order of operation in college algebra or arithmetic is the same as in Java, the order of operation. So next, we're going to see a program that will convert temperatures. So for example, we may ask a user either to enter the Celsius, and the answer will be in Fahrenheit. Or we may tell the user to enter a Fahrenheit, the answer will be in Celsius. But in this program, we ask the user to enter Fahrenheit, then we find the Celsius. We know in arithmetic, to find the Celsius, it's 5 divided by 9 times the degree in Fahrenheit minus 32. So for example, this means if we enter 30 degrees in Fahrenheit, then I'll get 5 by 9, 30 minus 32 times 30 minus 32. Now, sometimes we may talk about Java data types. If I divide the value, let's say 5 by 3, instead of getting 1 point some decimal values, if the data types are integer, a whole number, the decimal part will be truncated, will be removed. So let's say if everything is a whole number here, this formula, we have 5 over 9, the Fahrenheit is an integer. Let's say our answer was 5 over 2. Then 5 over 2, the answer will give us 2. But if we change the 5 by 9 to at least one of them to decimal, which is we normally call double or float in Java, then my answer will be 2.5. So let's say well, write 5 divided by 2, the answer will give me 2. But 5.0 divided by 2 or 2.0, the answer will be 2.5. So that's why here we are saying that we can write, instead of writing 5, we wrote 5.0 so that we get the decimal answers. So let's see the program. So right now we know the formula. So writing this program will be 3 steps. First, we need to get an input from the user, which will be Fahrenheit. Then we process, we find the Celsius. When we get the answer by using the formula, we are going to print the answer. So input, processing, and output. And remember our previous lectures, again, we talk about Java is again object-oriented programming from the beginning. So any Java program must have at least one main class. So we are still starting with our main class here. And we said that the main class name is the name of the Java file. So here our main class name is Fahrenheit to Celsius. So this file, the name will be Fahrenheit to Celsius.java. Now we can see we have a new statement here, import java.util.scanner. Remember we discussed this previous lecture. Scanner allows us to ask a user to enter an input. And scanner, in order to use it, the scanner class, in order to use it, we need to import the java.util package. So if we like, we can write import java.util.asterisk and semicolon. This means I'm going to import all the classes in the java.util package. So here we are importing only scanner class. So we have import java.util.scanner. And Java always end with semicolon. So semicolon is like a statement terminator, or like in English, instead of ending the sentences with period, is the same as in Java, we end our sentences with semicolon. So we import, and always we have to import our package first outside the main class. So that if we have more than one class, or we have another class, or even outside the main class, the scanner class can be used. Now, if I import a package inside the main class, that means only the main class can see the package. But conventionally, always we import, and the import package statement should be outside the main class. So here again, we have the same thing we discussed previously. We have our main method. And now we create our scanner object, which is called input. We need this first because we want to ask the user to enter the input. So as we said earlier, this program is input, processing, output. Input will be get the degree invariant. Process will be use the formula to find the degree insertions. Output will be print the result out. So we create, since we are not asking the user to enter input, and we are going to use the keyboard, we use the system.in. In the future, we're going to create a scanner object, but we are going to use the file system. So our input will be information from a file that is installed in our program. But for now, again, we are using the keyboard. So we use the system.in for the keyboard. So here we have scanner input equal to new scanner system.in. Now we have the instruction to ask the user, enter a degree invariant. So we are asking the user to enter the degree invariant. Now we need to store the degree invariant in a variable. So we declare a variable named Fahrenheit. Remember, Fahrenheit is not a reserved word in Java, so we can name a variable as a Fahrenheit. And as we said earlier, naming variable, always name the variable. The name should be about the content of the variable. So for example, if I say double x equal to input dot next double, we don't know what is in x, and maybe we can guess it by just going through. But by naming it Fahrenheit, it means maybe the value there is in Fahrenheit degree. So again, the syntax, the data type of the variable, and the variable name. We are using the scanner object and also the method next double. The reason why we are using a next double because the data type of the variable is double. So we are going to, now if the data type is int, we are going to use next int. We may discuss this also in the future lectures. So that's it. We get our input now. So it's 3 steps here. We declare our variable double Fahrenheit. Then we use the scanner object that we create. Always we need to create our scanner object using the scanner class. Then also, since we are using a keyboard, always if you are using keyboard, the argument for the scanner class will be system.in. That's for keyboard. Then next step, we ask the user to enter the Fahrenheit and he enter it. Next, we are going to do our process now, convert the Fahrenheit to Celsius. So we use the formula 5.0 divided by 9 times Fahrenheit minus 32. Remember, this will be decimal value, or we call it the double. So this means our result will be in double. So that's why we declare Celsius also as double. Fahrenheit is already double. We don't want to lose the decimal numbers. We want the decimal numbers. If we declare them integer, again, as we said earlier, the decimal numbers will be removed. So we finish with the process. We use the formula to find the degree in Celsius. Now we want to print the answer. So we say Fahrenheit is whatever is in Celsius. We said if we want to print the content of a variable, we can, the reason why we are using the plus sign here, this is to concat the string and the number together. So plus allow us to join the string is, there's a space, we have a space inside the quotation, is whatever value is Celsius. And then we are joining to another string. So plus is joining either a value with a strings. In this case, the variable again is a value. It can be int, double, etc. with a string. So that will be our conclusion here. Again, the new thing we are learning here is the formula, how to write Java arithmetic expression, and also we went through the plus sign, which is the cognate to join a string with a value. So let's run this program and we should see the result down. So this is again a simulation system. The user enter 100.54. And when we enter 100.54, the compiling was successful. And here the answer was the Fahrenheit 100.54 is 38.077778 in Celsius. Again, since the data type is double, it can take up to 15 decimal places, which we normally call the precisions. If it's a float, it takes up to 7 precisions or decimal places. So we can see the output of our program. Enter a degree in Fahrenheit. If you remember, this is our first statement we have before we use the next double method to extract the input to the variable Fahrenheit. Then our output, there was a sentence saying Fahrenheit. When we say Fahrenheit, the Fahrenheit variable will consist of whatever input that we enter. In this case, 100.54 is the answer we get from the formula will print. So that's what it's printing here. Fahrenheit 100.54 is 38.077778 in Celsius. The last section in Celsius, we can see the string in Celsius. So again, that will be the conclusion for our first program. Again, this program, we are converting the Fahrenheit to Celsius. First thing we do, ask the user to get our input. Then we do our processing. Then we print our output. So we have another program again to display a current time. So for example, we have a current time in our computer system. It's going to display it. So let's see this program. So here we have our main, again, here we are not going to ask the user to enter input because our input will be the computer current time. So we have our main class, show current time. So that will be the class, the file name. Then we have our method. First thing we're going to do, we are going to obtain the total milliseconds since midnight, January 1st, 1970. So this gives us total milliseconds. Again, that's the variable. We declare it as a long. Long is a whole number, it's an integer, but long carry larger values. So since this value will be very big, we use long. Int doesn't carry big value. So again, we may go through data when we discuss Java data types, then we will see the different sizes. So we declared here, we want to get the total milliseconds of the current time. So if the current time is 1 o'clock in the morning, then the total seconds will be 3,600 times 1,000 will give me milliseconds. So when we get the total milliseconds based on the time, this is our current time millis. So this is a method that will extract the current time from the computer system. And we are going to store that current time into a variable known as total milliseconds. And the current time will be, that's why it's called current time millis. The current time will be in milliseconds. Now we want to obtain the total seconds since the midnight. So since the method, again, the current time millis or seconds is a built-in method in the system in Java library file. So anytime we call this method, what we get is the current time in milliseconds, but we want to know the time in hours, minutes, and seconds. So the first thing we do, we convert the milliseconds to seconds, which means we divide by 1,000. And we put that result in a new variable known as total seconds. Then we want to find out if there's any remainder. So we say compute the current seconds in minutes in an hour. So we obtain the total seconds modulo 60 will give us the current seconds. What this means is that, for example, we have 57 seconds. We know 57 seconds is not 1 minute. It's not 1 minute yet. Let's say we have 122 seconds. 122 seconds will be 2 minutes, 2 seconds. We want to get that 2 seconds. So when we say total seconds modulo 60, means if we have any value less than 60, that will give us the current seconds. If we have any value greater than 60, then when we divide that value by 60, the remainder, that will give us the current. So if I have 125, I will get 2 minutes. The current seconds will be only 5 because 2 minutes is 120. So 120 will be given from, will be deducted from 125. So 5 seconds will be left. So after we get the current seconds, we want to know again the total minutes. So we have 125. 125 modulo 60 will give me 5. So it's only 5 current seconds. Then the current minute will be the total seconds divided by 60. So in this case, 125 divided by 60. Now 60 is an integer. So the remainders will not be counted. So it will give me 2 minutes because 120 divided by 2 is 60. Then after that, we also want to get the hours. In order to get hours, we want to get the current minutes that will be left. So since hours also is in 60 minutes is 1 hour. We do the same step, but this time it's total minutes. We are not using current seconds. So we use the total minutes we have now, modulo 60. So if the total minutes again is 122, then current minutes will be 2. Then I will get 122 divided by 60, which will give me 2 hours. So after I get the current minutes, the remaining, I'll divide by 60, then I get the hours. Then to compute the current hour, again, it will be the total hours modulus 24. We know 24 because why? We have the seconds. How many seconds make a minute? 60. How many minutes make an hour? 60 minutes. And then how many hours make a day? 24. So that's the whole idea here. So now we have we don't need a total because we want this time to be in hours, minutes a second. So we get the current seconds, which is right here. Current second should be last. The middle will be current minute. And of course, our last will be the current hour. So then we print it. So again, in this program, we are using the current time millis, which is a built-in method in Java to get the current time of the computer system. Since the current time of the computer system will be in total milliseconds, we are going to convert it so that, again, it will be in hours, minutes a second. And that was the process here. So we also use the modulus operator to get the current seconds, modulus operator get the current minute, modulus operator to get the current hour. So now we're going to start with the theory aspect of the two programs that we went through. So this is called the augmented assignment operators. When we have a plus and equal, it's called the addition and assignment because it's addition and assignment. So here, if I write I plus or equal to 8, is the same as saying that I equal to I plus 8, which means I'm going to add 8 to I, the previous I value, and that will give me a new I. And the same thing if we say I minus or equal to 8, it means I'll get I equal to I minus 8. I will subtract minus 8 from previous I. The answer I will get will be our current I. The same thing we have for multiplication, I multiply equal to 8 means I equal to I times 8. I divide equal to 8 means I equal to A divided by 8. Always the arithmetic operators come first before the equal sign. So again, the percent here is our modulus operator. So if I say I modulus equal to 8, it means I'll divide I by 8. The remainder I get, I'll give to the new I. We also have what we call the increment and decrement operators. Increment operators means we're going to increase by 1. Decrement operator means we decrease by 1. But also we have a pre-increment and post-increment. Pre-increment means I'm going to add before I assign the value to the variable. So increment var by 1 and use the new var value in the statement. So if I say int j equal to plus plus I, and I is 1, I'm going to increment I to 2 before I will assign it to j. So j is 2 now. And I also will be 2 because you increment the I first. But look, when we do the post increment, which is var plus plus, we increment the var by 1, but you use the original var value in the statement. So if I say int j equal to I plus plus, in the pre, we increment I, then we assign it. But now see what happened. J is still 1 because we get the j result first before we increment I. So that's why it's called post increment. Do the arithmetic operation first, then you increment the I. So here we assign j to I, and original I is 1. Then we increment it to 2. But pre-increment means first we increment I from 1 to 2, then we assign it to j. Then I also is 2. The same thing applies to pre-decrement. So since this is pre-decrement, it means we are going to decrease first. When we find we decrease it before we assign it to j. So here we still have I equal to 1. So if we say minus minus I, it means we are going to decrease I by 1, which will give us 0. And also we assign the 0 to j. So we perform the arithmetic operation before we assign. So we get 0, 0. But if it's var decrement, again, this means we are going to assign our original value I to j first before we decrease by 1, which will give us 0. So here we can see j is 1 and I is again 0. So this is an example. Here we have int I equal to 10. And next we say int num, new num equal to 10 times I plus plus. So this means again is post increment. So we get 10 times I first before we increment I. So let's say if I is 1, then we get 10 times 1, which is 10, then I is 2. So we say 10 times I, because this is post increment. Multiply 10 times I before you increment I by 1. But pre-increment, what we do first, we increment I first before we multiply by 10. So again, that's the difference between post and also pre-increment and decrement. So here we say using increment and decrement operators makes expressions short, but it also makes them complex and difficult to read. So we should avoid using these operators in expressions that modify multiple variables or the same variable for multiple times, such as this. So we know prior to Java 2, all expressions can be used as a statement. All the expressions, we can use it as a statement. But since Java 2, only the following types of expression can be statements. So we have a variable operator equal, this will be, we also use the term compound operator, let's say plus equal expression, where the operator or OP is arithmetic operations. Plus, minus, multiplication is asterisk, division, or percent is modulus. Modulus always gives us the remainder of a value when two values are dividing. So we have the plus variable or variable plus, which is pre-increment and post-increment. Minus variable means pre-decrement, then post-decrement. So if I have a byte equal to 100 and long k equal to I times 3 plus 4, and double D is I times 3.1 plus k divided by 2. So these are called the Java data types, byte, long, and double. And we can also do a conversion of this data type. So we go through the conversion rules now. Here they say when you are performing a binary operation that involves two operands of different types, Java will automatically convert the operand based on the following rules. If one of the operands is double, the other is converted into double. So if I have a double divided by int, my answer will be double. Otherwise, if one of the operands is float, the other is converted to float also. Otherwise, if one of the operands is long, then the same thing, the other is converted into long. Otherwise, if both operands are converted into int, then the same thing also applies. This will happen implicitly. So type casting. Here we have double D equal to 3 is type widening. And now we have explicit now. The explicit casting, we always show the data type we want to cast. So here we have int I equal to int 3.0. The goal is to convert 3.0 to int, which will give us 3. 3.9, again, casting is not the same as approximate. So 3.9, 3 will be gone. 0.9 will be gone. So the answer will be 3. The fraction part is truncated. This is casting again, not approximate. Now we have a question here. What is wrong? You have int x equal to 5 divided by 2.0. And the range will increases. So the type can be byte, short, int, long, float, and also double. So let's see this program keeping 2 digits after decimal place. So we have a short program here. Again, we are importing the scanner class because we are going to ask the user to enter a value or an expression. So we have our main class named CellStars. Then we have our main method where the execution will take place. The first thing we do here again is to create our scanner input object. So our scanner input object is named input. We are using a keyboard. So system.in. Now we have instruction telling the user to enter the purchase amount. The purchase amount data type is double. So we use the next double with the input object to get an input from a user through the keyboard and enter that amount in purchase amount. So we declare variable here named purchase amount. So now we are going to do the process. Here we are going to say the purchase amount times 0.06, the tax is 6%. So whatever the purchase amount is, we multiply by 0.06. And that gives us the tax. The tax is in decimal number, so we use the data type double. So after that, we're going to print our output. So system.out.println, we have a string saying the sales tax is with a space. Then we want to convert it to int. So it will be int tax period 100 divided by 100.0. So again, this program is the same as our previous. We are doing some input here. Then we do our process to find the task. Then we display our result. So let's run it. Yeah, again, it's a simulation system. The user enter 197.55. So after we enter, the set stars was calculated to be 11.85. So casting in an augmented expression. Here we say in Java, an augmented expression of the form x1, the operator can be again any arithmetic operator equal s2 is implemented as s1 equal to t, s1 the operator s2, where t is the type of s1. Therefore, the following code is correct. We can say int sum equal to 0. We initialize the sum to be 0. So next we can say sum plus equal to 4.5. And then sum becomes 4 after this statement. Why? Because our sum, we have the data type int. Or we can say sum plus equal 4.5, which is equivalent of saying we convert the answer to int. So sum plus 4.5 or int. So again, that will be the conclusion of our lectures. Again, in these lectures, we went through the basic concept of Java syntax. We saw how we can write a Java program starting with the input, processing, and output. We use the scanner class with the System.in to get an input from a user using the keyboard. And we saw how to write the formulas, arithmetic expressions in Java syntax to perform the process. Then we print our output. So again, see you in the next class. Thank you for your time.